Okay, guys, welcome to the last lesson of this week, lesson 108. So after this lesson right now, and after this week, we only have 12 lessons left of the whole book. It's crazy. So we have 10% of the book left. So today marks the 90th percent of what we've done. So it's a lot, 108 lessons, because 9 times 12 is 108. That's what we're going to be doing today. And so today's lesson, I have to get close to the book so I know what we're doing, because I remember. Oh, okay. Yeah. It's identifying and graphing exponential functions. So exponential functions, and it's really interesting that during these times we have to talk about exponential functions, because what happens is that what people don't know is that the virus right now, it is actually exponential growth. Because if one person gets it and then passes it on to 2 people, then already 3 people have it, right? But let's make it even easier. 2 people get it at one time, and so those 2 people pass it on to 2 other people, and so that's 4. And those 4 people each pass it to another 1 person. So then instead of having 4 people, now we have 8. And those 8 each pass it to another person. That's 16. And 16 makes 32, 32, 64, 64, 128, 128, 256. 256 makes 512, 512, 1024. And this is how it snowballs. Because what happens is that it's exponential, the growth. And this is scientific / mathematical. And this is what we're going to be talking about, the exponential growth, which is something that is ridiculous. And it does happen in real life. And a lot of you are like, no, I'm never going to use math in real life. But right now what's happening in the world with the virus is that we are experiencing exponential growth of the virus. And this is one of the reasons that they need the social distancing, so that they can cut off all these little trails of the virus infecting more people. And that's why it's important for you to follow this advice. It's not for you, it's for other people. But it's also for you. I mean, the virus seems to be mutating, but I don't want to freak you out or anything. So let's cut it there with the bad talk, and let's actually talk about math, because this is actually pretty interesting. So let's get into it. All right, so exponential functions. This is the parent function. F of x equals, I forgot the equals, there we go, equals a times b to the x power. So that's what exponential functions means. Exponential functions means that x is the one thing that we don't know, and it's one of the variables. So x means the exponent is a variable. So what does this mean? So we start by very easy understanding how to substitute, how to evaluate is what your book says. So evaluate for -3, 0, and 4. Well, what are we going to evaluate when f of x equals 5 to the x power? So what we're going to do is, instead of the x here, we're going to put -3, we're going to put 0, and we're going to put 4. So the first one, for x equals -3. This is going to be the same as f of x equals 5 to the -3. Because the negative exponent means the reciprocal is going to be 1 over 5 cubed. And 5 cubed is 125, so it's going to be 1 over 125. That is what to the -3 is. So what about when x is 0? That is going to be super easy, because anything to the 0 power is going to be 1. That is just a property of math. So we're going to have f of x equals 5 to the 0, which is f of x equals 1. Okay? So that's it for the first 2. And then when it's 4, well, 4, I know what it is, because 25 squared . 25 squared is 625. I don't even need a calculator for that. And so f of x equals, 5 to the 4th power. So f of x is going to be 625. I almost said 25. No, it's 625. So that's the first example. It's going to be 125 for 3. is going to be 1 for 0, and it's going to be 625 for 4. Okay? So, moving on to the second part of the first example, which is, that's it for the first part. And so, what we need to know here is what we need to, how do we evaluate for -1, 1, and 2. For -1, we're going to use the same thing. X is going to be -1, and so it becomes f of x. I don't know whether to teach you this or not. It does make sense. I'm going to put f of 1. Of -1, I mean. And the reason is because if I put x as -1, then x is here too. So in here, I should have put f of 3. And in here, I should have put f of 0. And in here, I should have put f of 4. That's how you use that notation. The function is going to be what value at -1. And so the function is going to be this value, -1, which is going to be 2 times 4 to the -1. So because the negative means the reciprocal is going to be the same thing as 2 over 4 to the 1 power, so it's going to be 1/2. That's going to be the value of the function at -1. What about the value of the function at 1? X of 1. X equals 1. So f of 1 equals 2 times 4 to the 1 power. So f of 1 is going to be 8. And finally, we have x to the 2 power is going to be f of 2 equals 2 times 4 squared. 4 squared is 16. F of 2 is going to be 32, because 16 times 2 is 32. And so that's the first part of this lesson of exponential functions. And so let's move on to what example 2 and 3 want you to do with it. By the way, disclaimer, it's not like you're going to get too in depth with it, because you're going to do cubic and even quartic or polynomial functions in Algebra 2. So it's not like we get very deep into it. It's kind of like the surface and understanding what could happen. So let's get into this one. Okay, so for example 2, what we need to understand if it's exponential or not. So to be able to understand whether it's exponential or not, you kind of have to look at this part in your book. The first part right here, change of 1. So what it means is that for every x right here, it's changing by 1. -1 to 0. Sorry. -1 to 0 is plus 1. 0 to 1 is plus 1. 1 to 2 is plus 1. 2 to 3 is plus 1. So every time we're adding plus 1. But what is happening here? Well, from 2 to 4, we multiply by 2. From 4 to 8, we multiply by 2. From 8 to 16, we multiply by 2. From 16 to 32, we multiply by 2. So the change in the f of x, or the y part, is that we are multiplying by 2. And so we understand here that the base is a 2, but there's always an exponent. And so that's what it's saying. It says the base 2 of the exponential function f of x equals 4 times 2 of x is the common ratio of the sequence 2, 4, 8, 12, 16, and 32. So the base is what it's in between, in the parentheses right here. The parentheses, that's the base. The base is what you're racing to. I don't think I have to go over the exponent. So in example 2, it tells you, okay, let's identify whether or not these values are given you an exponential function. So step 1, always arrange them from least to greatest according to the x value. So 0, -2, 1, -1. So it has to be arranged. -2 first, then -1, then 0, then 1. And this is literally how they did it. -2, -1, 0, 1. Okay, so that's how you do that. So now what we're going to do is we're going to divide -9 by -3, and we're going to get that it is 3. Then we're going to divide -3 by -1, and we're going to find that that would be 3. And then we're going to divide -1 by -1/3, and we will find that it's 3, as you can see right here in this part. And so, because the ratio is the same, always 3, the base is going to be 3, and so this is going to be an exponential function because it has a common ratio. This has to do a little bit with geometric sequences, and that's why we did geometric sequences before we did this lesson. So let's move on to example 2b, which is the same thing, right? So the same principle. You have to get these in order from x. So first you're going to have the 2, then you're going to have the 4, then you're going to have the 6, and then you're going to have the 8. Right? And so after you do all of that, what you have to do is you have to look at the different values. So it's right here, right? So you're going to divide 200 by 150. 200 by 150 is going to give you 4/3 or 1.5. 4/3? Yeah. 4/3 or not 1.5, 1 1/3. 1 1/3, right? So that is what we get here. You see right here. This is what they did. They did 200 divided by 150 equals 1 1/3. That's okay. That's something. But then we divided 150 by 100, and we got 150 divided by 100 is 1 1/2. And then we got 100 divided by 50, which is 2. And so right here, because the ratio is not even close to being not even close to being something constant, meaning like in the top example where it was all 3, it is not. It is not the same thing as an exponential function. And so that's why I wanted to do it in the book, because it makes more sense in the book that if I write it down and I just talk you through the example. So that is example 2. Let's move on to example 3. All right, example number 3. I'm going to actually teach you how to do it manually in this particular example in 3A, and then we're going to do 3B and 3C in your calculator, and that way you can actually see in example 4 how to use your calculator, which I'm not going to go over because if you use your calculator, you already know how to do it. So what I'm going to do is I'm going to show you how to do it first manually by hand, and then in your calculator for example 3B and 3C, and that would be it for lesson 108, 90% of the book. And so, to be able to do this, you have to obviously do a table. X first and then Y. Always X first, then Y. Okay, so that's your table. And you do have to select negative values and positive values, okay? That's what your book tells you. It says choose both positive and negative values. So we're going to choose the easiest positive and negative values. We're going to do -1, -2, -1, 0, 1, and 2. Those are pretty easy, I think. And so we're going to, when x right here, the exponent is going to be -2. So it's going to be -2 is going to mean that it's going to look something like this. 5 times 2 squared. So it's going to be 5/4. 5/4 is the same thing as 1.25. Okay, so 1.25 is going to be my first y value for -2. When x is -2, y is going to be 1.25. When x is -1, so it's going to be 5/2. 5/2 is going to be 2.5. Right? Yeah, 2.5. Yes, and for 0, when x is 0, so this one's going to become 5. For 1, it's going to become 10. And for 2, it's going to become 20. So look at how my graph is going to look. This is my y-axis. This is my x-axis, which starts at -2 -1, the counting, then I have 1, then I have 2, and then in here I have to have it by 5. So I'm going to do it by 5s because it's easier that way. And this is one of the reasons I don't want to keep on going, doing it manually, because I know that my y-axis, it's going to have huge intervals in between. And this is what I mean. For x0 is going to be y5. For x1 is going to be y10. And for x2 is going to be y20. For this one is going to be half of 5, because 2.5 is literally half of 5. And for this one is going to be 1/4 of that. And so it's going to look something like this. It's going to keep going. And that's what the exponential function should look like. It should look like a graph that goes up. And so this is supposed to not be very hard to do it by hand, and that's why I wanted to teach you how to do it by hand. But now let's look at the next 2 examples in your book, and then in your calculator, which is super easy to do. So let's actually go over this. Again, so hopefully you have your calculator to go along with me. So we're going to enter this one right here, y equals -3 to the x, right? And so you turn on your calculator, you go to y equals, obviously, you clear what you were doing, right? So it has nothing. By the way, please make sure that the plots are not on either. The ones on top, that they're all off, that it's just like that. And then we're going to put negative, which is this one right here. It's not this one minus, but it's negative. Negative, right? Negative. And then, yeah, let's put the parentheses too. So the parentheses are obviously right there. To the, and by the way, to actually do this, where you put the exponent, you have to use the caret right here. This is the caret. So I'm going to go back to what I had, right? Negative parentheses 3, close parentheses. Then in here, I'm going to have the caret. So I just press a caret, right? And look at what happens. It goes up, and then I just put the x, right? The x right here. Boom. I press it, and I'm done. And that's it. And so now I'm going to graph. And look how it looks. It looks very similar to what I have right here, that it's coming down. But I told you, look, the reason I didn't want to keep on doing it manually is because it's -8, -16, -24, and it just keeps growing and growing, because if you look at the table, it goes from -1/3 to -1 to -3 to -9 to -27, and it will keep on going bigger and bigger and bigger. And that's why I wanted to show you that. And obviously, you can always check the table here by pressing second and then graph, and you will see the table. So in here, if we look at -1, it's -0.33, but we know that's -1/3. And so in here, we have exactly the same table, even bigger than what we have in the book. All right, so now let's do example 3C, which is the last example of the week. Woohoo! Yeah. April 3rd, we're done for math, at least. In this class, I have to do more stuff for other classes. Story of my life. And they extended the thing until April 24th. So, oh yeah, praise the Lord Jesus all the time, because God is good all the time. So then we have this one, and I cleared it. The first thing I did was cleared it. I don't have anything in my y equals, right? I cleared it. And so I'm going to put 6 parentheses, 1/2, close parentheses, x, right? And so I'm going to put 6 parentheses, fraction, 1/2, close parentheses, x. So that it has to look something like this. That's what it's going to look like when you enter it, right? Look, it's the same thing right there. I was trying to show you with the calculator, but the camera focuses what's closer to it, so it's important for me to move the calculator so that you guys can see this. So y equals this. Look at that. The calculator has that. And so look at how the graph looks here. Okay, it goes backwards like this because the other ones were going either downwards or going upwards like this. This one's going to go like kind of downwards, and the reason it's going a little bit downwards or downwards like that is because of the 1/2, because it's not a whole number in the parentheses. It's going to go that way. And now look at what my graph looks like. Oh no, it broke. It doesn't work. Oh no, just kidding. It does. Here it is, and that would be the graph. So now you know how to do it, and if you want to know how to, like, quote unquote, compare graphs, what you do is I'm going to compare it to the graph on 3b. I'm going to put -3 to the x, right? And so I have two graphs right there, and boom. I graph the other one, and look at what it looks like. So this is 3c, this is 3b, and so that's what you have to do for example 4. Quote unquote, you have to compare. And so you can compare on your calculator. I'm not going to make you do things that make no sense on the board and on paper. I always tell you, keep math simple. And so this is the easiest way to keep it simple. All right. So you know what to do. You can the calculator's in the way of the like. You can like, all right. You can comment. You can comment down below, obviously, and you can do all those awesome things. So thank you for watching another one of these videos, and I will see you next week. Woohoo!